Okay, so we will start with this particular data structure present in Python, which is very useful in some situation. The data structure name is set. As you know, this particular word is very common in mathematics, and you have played with lot of different type of states in mathematics in different way. The same logic is applied over here as well. What I mean is that you can apply, you can design a set or create a set of some elements. Now, since I'm saying it is set, so naturally it is definitely following the rule of set theory. That means all the set theory operations that exists in mathematics can be applied over here as well. And how we can basically um, create a set, it is something like this. For example, over here you can see it is created something like animals equal to, so there are some animals name is given, but you see one thing is very important here, that how we have declared it, we have declared in a second bracket, but you see the second bracket was present in case of a dictionary as well. In case of a dictionary also there was a second bracket, something like that. But the difference over here is that in case of dictionary, you will have a key value pair or something like this. It is not only data present, it is the data is present based on a key value pair. The first one is the key and second one is corresponding value. For example, first name is a key and its value is John. Second, last name is another key whose value is Doe, something like that. But in case of set, there is no such exact key value pair you will see, only directly value is given. Anyway, as you can see here, that animal is a set created here. Similarly, there are two more sets has been created, as you can see here. Now, as I told you that you can create any set over here with following the rule of set theory. So naturally, this is a way of adding new elements in the set. So the set name dot add is a function, a predefined function given with set, where within the function as a parameter you can pass the particular element that you want to add in the set. So for example, here salmon has been added in the set of animals. So if you particularly print this particular thing, it is showing it is a set. Why? Because it is printing the type. You see, sorry, it is printing the type. But if I just print animals, so that means it is going to print the set animal. That means the elements that present in the set. For example, something like this. Okay. Now in the second cell, what basically we have done here, we have written something like animals minus mammals minus aviary. This is nothing but, we all know there is a set theory operation which we call set difference, which says that x minus y, which will give output those elements which present in x but not in y. That means here also animals minus mammals minus aviary, it will give the elements which present in animals but not in mammals and aviary. So if you compare these three set here, you will see that uh, if you just compare, you see that cow is already present in this set. So cow will cow will be nullified. Donkey is also present here. Chicken is also present here, and sparrow is also present here. So what are the things that is remain in this set? You will see that This salmon is an element which is not present in mammals or aviary, any two set. Similarly, trout is also another element which is not present in these both sets. That's why if you print this particular swimmers, you will see it is coming salmon and trout as a set difference operation. Similarly, if you see this part, you will see it is given a or sign. This particular sign is very common for C language programmers. Since you are already have idea of C language and you have used this particular or sign for bitwise or operation. But what does or means in set theory? In or means in set theory is nothing but union. So definitely that means it will go for a union of two sets. And I hope you already have idea what does union operation mean in a set theory. It means that whatever is common that will come, and also the uncommons will come. That means in case of mammals and aviary, you will see that the common basically present nothing. All the elements are uncommon to each other. So naturally, we will see all the elements here: chicken, cow, donkey, and sparrow. Now, an interesting point is that, for example, suppose there is a common. For example, suppose we are doing a OR operation with one more set directly here. And for example, suppose I have given some set the elements something like chicken and cow. Okay, these are the two elements I want to do a union. So after union, what will happen? Don't think that this chicken will come two times, because we all know that in a set theory case, say, according to set theory, in a particular set, you will not have any repetitive element. For example, if I say that set of, if I say that a set of integers between 1 to 10, it does not mean that 2 is repeated two times, right? Maybe 2 is present. If 2 is present, it will present only once. So that's why if you do our OR operation with this, you will see there is no change of the number of elements present in the set, because although chicken is already present here in mammals, I'm sorry, in aviary, since you are doing OR, so this chicken is not coming two times because it is a common, so only the common will come. That is the very important observation you should have while working on set. Now similarly, as you can see in this part, this particular element represents the concept of superset. What does it mean? It means that we all know superset mean the set which already have all the elements of some low another set. Why it is saying true? Because Walker, if you check the Walker set, sorry, if you check the Walker set, this one, you will have these four elements here, right? So, and if you check the mammals set, in the mammal set we have cow and donkey. So naturally you can say that the the elements of mammals set is already present in Walker set, maybe more than that, and that's why Walker is saying considered as superset, and that's why it represents true. But if you do the opposite one, for example, just to show you here, if I cut this and try to do just opposite one, this one, it will show false. Why? Because the elements present in Walker set is not all elements present in mammal set. For example, donkey does not, sorry, sparrow does not present in mammal set, or cow, sorry, chicken does not present in mammal set. So naturally, mammals cannot be a superset of workers. That's why it is giving false. So these are the set operations sometimes you require in various cases. But remember one thing, that we need only set operation in only those cases where we have to have something like, uh, for example, you can say, somehow you don't want to make mistake and you don't want to keep a element repetitively in your bucket. Okay, repetitively in the sense that suppose you are going through some, you are scanning some data, okay, from an area or something like that, and what you want to put some elements in the set. Now where it is useful is that if you somehow by mistake put a same element to the set, in the set data structure the same elements will not be repeated. If you don't want repetition, you want only unique elements, then you can keep as a set.